Welcome to homework number 2 lecture. We're going to be talking about signed numbers. So last time we dealt with like the basic number line concept. We talked about natural numbers, whole numbers, rational numbers, and a bunch of other things. But now what we're going to get into is a little bit more number line stuff and a bit of basic algebra and some basic arithmetic. So this section covers a lot of different little topics, but all of them build on each other, but they're not inherently difficult except for the adding and subtracting. Sometimes I might require a bit more thinking in order to get those down, because I remember it did for me when I was first learning this stuff. So let's start off things by talking about the number line and what it is. So the number line looks something like this. It's a line with numbers on it, right? Hence a number line. Not very creative in the math world, right? We're very literal, so the number line. We learned last time that these numbers right here are considered integers. So all of those are the counting numbers on positive and negative components. Anything in between, like 1 and 2, would be numbers like 1.1, 1.5, anything in between them would be a decimal. So over here, anywhere in between here, I might have negative 1.5 there. I might have negative 2.5 here. Remember, those are rational numbers. So we talked about last time, rational numbers can be any terminating decimal or any repeating decimal. You'll always see numbers in between the two integers as rational numbers, or even irrational numbers like we talked about with pi last time. I think I mentioned pi. Pi is like 3.14. It would appear somewhere right here. That would be pi. So rational and irrational numbers appear in between integers, whereas the integers themselves are the counting portions of it. So what we want to do is we're going to talk about comparing two sets of numbers. So let's take the negative 5 and 9, these two numbers. What we're going to do is we're going to compare them with what we call a less than or a greater than symbol. So if I have this symbol right here, this means less than. And if I have this symbol, this means greater than. So it's then with a THAN because we're comparing something. Whenever we read these, we read them left to right. So what that means is here the point is right there, and then this is the bigger part. So we read it as less than. Here the opening is on the left side, so we read it as greater than. You might have learned back in, I don't know, grade school or something, where if you have like a greater than symbol, the alligator wants, or less than symbol, the alligator wants to eat the bigger number, right? So that's the way I remembered it when I was learning it as a kid. It's always going to face the larger number. So in order to compare numbers, let me go ahead and erase these real quick. Let's just keep a basic example. If I have the number 3 and 1, we know that 3 is larger than 1. So what we would have to put right here in between them is a greater than symbol, because 3 is the larger number out of the other number, which is 1. If I switch the numbers around, if I just put 1 and 3, they're the same exact numbers, but I switch them around, our symbol also will flip around. We'll say less than, right? So here we say greater than. 3 is greater than 1. 1 is less than 3. So it depends on which way you write it. The symbol can change, but notice it's always opening up to the larger number or pointing to the smaller number. So that's what we do. On the number line, we can see that 3 is greater than 1. So when we're talking about the number line itself, any numbers on the right side that are more positive are going to be larger than any number that's on the left side of it. So I could say 3 is larger. 3 is larger than 2, 1, 0, negative 1, negative 2, negative 3. Or 4 is larger than 3, 2, 1. Or 4 is larger than pi. Where it gets a little confusing for some is negative 1, since it's further to the right, it's larger than negative 2. So negative 1 is larger than negative 2, it's larger than negative 3. Negative 2 is larger than negative 3, but it's smaller than negative 1. So we want to compare some numbers here really quick. Let's pull up two random numbers and we're going to compare them. We pull up that -5 and 9. Since 9 appears more on the right side of the number line, 9 is going to be larger. So -5 is less than 9. Again, if I switched them around, I would have to switch the sign around. 9 is greater than -5. Let's say I have 0 and -1. Well, 0 is further to the right than -1, so we have to say 0 is greater than -1. 0 is larger than -1. What if we have two negative numbers, -5 and -7? Here we would say -5 is greater than -7 because it's further to the right. So since it's further to the right, that means it's greater than -7. Now, where it might get a little tricky, let's say I have 1.5 and 1.6. Well, 1.6 is larger than 1.5, so I'd say 1.5 is less than 1.6. Now, if I change it, let's say I use negative numbers instead, -1.5 and -1.6. If I draw like a little number line, -1.5 would be here and -1.6 would be over here because it's more negative. So since -1.5 is further on the right side, -1.5 is larger. What if I compare 1.01 and 1.001? Well, remember this number right here, that's 1 right here. This is 1/100th. Here it's 1/1000th. So 100th is bigger than 1,000th. So this would be greater than. If you'd like, remember what we went over last time is we could add zeros on the end after the last digit on a decimal. And then if we compare them, we can see that the 0 and the 1 are right here, and we can see 10 and 0, 1, so it's still greater than. Either or works. Now again, if we did the other way around, what if I put negative numbers, -1.01 and -1.001? Well, this number is larger, quote unquote, in terms of being more negative. It's more negative. So since this number is more negative, that means this number is actually greater because it appears further on the right side of the number line. So that's where a lot of that stuff can get tricky, keeping track of your greater than and your less than signs. But comparing the two with those two are the most common ways of comparing the two numbers. Not going to have anything terribly too difficult on the quiz, but there's going to be a few like that. Just get comfortable with knowing which numbers are bigger, which ones are smaller. Let me get like a fraction, for instance. Let's say if I have 1/3 and 1/2. Well, we learned that 1/3 is a repeating decimal. I can convert 1/3 to 0.3 repeating, so it goes 0.33333. 1/2 is 0.5. So converting it to a decimal might help. Some know that half of like a pizza is larger than 1/3 of a pizza. So what you do is you say 1/2 is larger than 1/3. 0.5 is larger than 1/3. But what if the decimals are a little bit more tricky? What if it's something like, let's say 6/7, and we'll say 4/5. So if it's like that, 6/7 and 4/5, if we converted 6/7, it converts to 0.857. And then 4/5 converts to 0.80. You can see that 6/7 is larger than 4/5. So comparing the two, maybe changing them to decimals will make it a little easier when choosing what sign we need to put. All right, so let's go into some arithmetic, adding, subtracting integers. Now, if we have something like this is like number 5 in the homework, -9 plus -7. Here we're adding two separate integers. It's -9 and -7. So you can think of it this way. -9 is already negative. -7 is even more negative. Whenever we see the plus sign, we want to think more. So what's happening here is we're saying take -9 and make it more negative by 7 units. So inherently what we're doing is we're adding a negative number. We're making it more negative. Think about maybe debt. You owe somebody $9. Now you owe them $7 more. So -9 plus -7 would make -16. So on the number line, what that would look like is this. If I start out at -9, I'm saying more negative. So more negative by 7 units would mean 1, 2, 3, 4, 5, 6, 7. So I can draw the different numbers: -10, -11, -12, -13, -14, -15, and then finally -16. So I kind of scrunched it in here. But you can see that we count 1, 2, 3, 4, 5, 6, 7 units over to get -16. So whenever we're adding negative numbers, we're making it more negative. Now, if we have, let's say, the subtraction sign, let's say I have something simple like 10 minus 8. So 10 minus 8, whenever we see minus, we think less. What this is saying, it's saying take 10 and then less positive 8 value. So that'd be 2. On the number line, that would be if you had 10, you'd have to minus 8. So minus 8 means make less positive. So then we're going to go ahead and jump 1, 2, 3, 4, 5, 6, 7, 8. That would bring us to 2. That's what minus 8 would be. Versus over here we had -9. And then we went to -16. Here this is plus -7. So inherently, plus, negative, and minus mean the same thing. And what we can do is we can convert the value and change it into a simpler way of solving an arithmetic problem. So it comes with this theorem. If I have some kind of a value plus some kind of negative b value, we can change that to a minus b. So if we look at this in terms of grammar, remember plus sign means more. Here, this one's saying more negative is the same thing as saying, remember minus means less positive. That's semantics, saying the same thing in different ways. If you make something more negative, it's inherently making it less positive. So again, you spend money on your bank account, you're making it more negative, right? Because you're losing money. Less positive means the same thing. You no longer have as much money in there because you're making it less positive by spending money. Now let's talk about subtracting and then subtracting a negative number. What if we have something like 2 minus -3? Here, 2 minus -3, if we think about it on a number line, we start at 2. Remember, minus means less, so we're making it less negative. So when we make something less negative, think about like paying off credit card debt or something. If we're making it less negative, it's the same thing as becoming more positive. So we would go 1, 2, 3. That would be this direction. Your answer would be 5. If you're making something less negative, you're making it more positive. That idea is kind of confusing, or at least it was for me when I was learning all this. So a different way that we can do this is we can convert using another theorem. If we have a minus negative b, that's the same thing as saying a plus b. Here we're saying less negative. That means the same thing as more positive. So ways that we can use this are with our arithmetic rules. Personally, I don't like seeing a sign and a parentheses next to each other, like a plus and a parentheses next to each other, or a minus and a parentheses next to each other. It gets confusing. So what we do is, instead of putting plus minus, we just change it to minus. And instead of minus negative, we just change it to plus. So let me demonstrate this on a couple of problems. And I'll write the theorems up here. A plus negative b is equal to a minus b. A minus negative b is equal to a plus b. All right, so let's look at number 6 from the homework. It says negative 1.6 plus negative 1.4. Now for me, that's a hassle. I'm like, oh, more negative. I don't want to think about it that way. What we can do is we can just change this plus and minus and follow this theorem right here. This would just become negative 1.6 minus 1.4. So now we start out with negative 1.6. We're making it less positive by 1.4. Since this is a negative and we're making it less positive, we inherently add the negatives, and that would equal to negative 3. Let's try number 7. This one says 20 plus negative 5. Again, you can say 20 plus negative 5, making it more negative, or you could just change it to 20 minus 5, and that's a little easier to read. So changing it, getting rid of the parentheses helps. Number 8, this one, negative 19 plus 14. This one doesn't have any parentheses changing or anything. But what you do is, remember, it's negative. You're adding 14. That would make it into a negative 5. So you start out on the number line at negative 19, and you're adding 14. Zero's way over here. Here you're saying plus 14. You didn't quite make it to the positive side of the number line just yet, because you haven't added more than what the negative number is. If, say, we had negative 19 plus 21, that would then become 2. Because negative 19 plus 21, this plus 21 surpassed that negative 19. We got out of the negative. I'll put a little star on that one, because that's one I just made up really quick. Okay, and let's apply this property to, say, a longer problem like number 16. It says 5 plus negative 2 plus 3 plus 4 plus negative 7 plus negative 6. If we want, we can get rid of all of the parentheses. So change this one to 5 minus 2 plus 3 plus 4. Change this one to a minus 7. Change the last one to a minus 6. Now with adding and subtracting, it doesn't matter what the order is whenever you're putting them together. You just put them together either from left to right or combine more than one. So for instance, I can choose to do 5 minus 2, get a result, and then rewrite everything else. Then add the next ones. I'll put it over here. That gives us 6 plus 4 minus 7 minus 6. Add the next ones. That gives us 10 minus 7 minus 6. Add the next ones. 3 minus 6 ultimately gives us negative 3. But what you can do, I'm going to copy this, is since it doesn't matter what order we add everything in, we can group up the numbers and make it a little easier for us. So I'm going to change all these to plus and minus with no parentheses. And me personally, I might want to group up, maybe add these two together, and these two together in one step. If I do that in one step, it makes my work less. So 5 minus 2 is 3. 3 plus 4 is 7. And negative 7 minus 6. So notice here, I got 7. I got a positive 7, so I'm going to put 3 plus 7. Here we're saying negative 7 minus 6. That makes negative 13, so we're going to put minus 13. Then what you can do from here is put together these two. That makes 10 minus 13, which makes negative 3. The order of which you do it doesn't matter. Say you have the same exact problem. I'm going to put the same exact numbers up. Some people might find it easier to not change and get rid of the parentheses. They might see all of the positive numbers. Oops, I didn't put a plus sign in between there. I'm going to go ahead and erase that. Plus negative 7 plus negative 6. They might look at all of the positive numbers and then look at all the negative numbers and add all of those up separately. So 5 plus 3 plus 4, add up all the positive numbers. That gives you a total of 12. Add up all the negative numbers. Negative 2 plus negative 7 makes negative 9. Plus negative 6 would give us negative 15. So we'd put minus 15. And then you're down to just two numbers. You get negative 3. So you get the answer in a bunch of different ways. There's different ways to get the answer for this particular problem. It doesn't matter. Let's look at number 17. Negative 11 minus negative 8. Going back to that other rule, we can just change these two numbers. Instead of minus negative, we can put negative 11 plus 8. And that would give us negative 3. Changing the sign ahead of time makes it a little easier. Me personally, I don't like thinking negative 11 minus negative 8, so I'm making it less negative, and that idea is a little bit more confusing. What about if we have, let's say, I'll make up another one. Let's say we have 4 minus negative 12. Again, change the minus and the negative. We can change it to a positive. That then becomes 16. All right, let's group all of our rules together now. Let's take 23. This one says 24 minus negative 16 minus negative 6. So looking at all of this, now what I probably want to do is get rid of all of the parentheses. So let's get rid of all the parentheses, and to do that, this could become 24 plus 16 plus 6. Remember, minus a negative becomes positive, minus a negative becomes positive. Now they're all adding. 24 plus 16 makes 40, and that makes 46. So using your addition and subtraction rules, again, these are the rules. If you don't remember them, or you can go back to the other slide. A plus negative b becomes a minus b. A minus negative b becomes a plus b. So now let's talk about multiplication and division. With addition and subtraction, you have to move across the number line. You got to see when you become a positive number, when you become a negative number. So like if I have, let's say, negative 6 plus 4, that becomes negative 2 because I have negative 6. And when I add 4, I'm not quite past that 0 line. Whereas if it was negative 6 plus 8, When I add 8, that gives me past the 0, so it becomes positive. Jumping across the positive and negative becomes a bit more difficult with adding and subtracting. With multiplication and division, you don't have to worry about jumping across the 0 to determine if it's going to be positive or negative. What you do is you depend on these 4 rules. If we have a positive number times a positive number, our result will be a positive number. If we have a positive times a negative, our result will be negative. If we have a negative times a positive, our result will be a negative. If we have a negative times a negative, our result will be a positive. So as an example, if we have 2 times 2, two positive numbers, they result in a positive answer. If I have 3 times negative 4, a positive times a negative, well, 3 times 4 is 12. And because it's a positive times a negative, it results in a negative. We put negative 12. If I say negative 6 times 2, a negative times a positive will result in a negative. 6 times 2 is negative 12. Then lastly, if we have a negative times a negative, the result is going to be a positive. 5 times 6 is 30. Same thing with division. If we have a positive divided by positive, we get a positive. Positive divided by negative, we get a negative. A negative divided by positive, we get a negative. And a negative divided by negative, we get a positive number. So if I have 4 divided by, I'll do a different color. Let's do like purple, just to differentiate. 4 divided by 2, that gives us 2. If I have a positive 9 divided by a negative 3, that would give us a negative 3. If I have a negative 12 divided by a positive 4, that gives us negative 3. And if I have a negative 100 divided by a negative 10, that gives us a positive 10. So essentially, the easiest way to remember this is if the signs are the same, it results in a positive for all of those. If the signs are the same, they result in a positive answer. If the results or the signs are different, like positive, negative, negative, positive, it results in a negative for all of your answers. That was the easiest way for me to memorize it when I did it back in the day. So same sign will always be positive when multiplying or dividing, not necessarily for addition and subtraction. So let's try some examples. I'm going to put number 26. It just says 2 times negative 26. Our rule says if it's a positive times a negative, our result will be negative. 2 times 26 makes 52. And that's all there is to it. So just determine what the signs mean. Number 27, negative 18 divided by 2. A negative and a positive result in a negative. 18 divided by 2 makes 9. Let's skip over to number 31. 31 has another problem like that. If we have 36 divided by negative 6, a positive divided by negative results in a negative. 36 divided by 6 is 6. And that's what we get. So these are some simpler arithmetic problems. You'll see them here and there. In larger instances with Pemdas, which is what we're going to talk about right now. So Pemdas, P-E-M-D-A-S. Pemdas is a way of remembering, it's like a mnemonic device, an acronym to help us remember the order of operations in which we have to do multiplication, division, subtraction, addition, parentheses, and exponents. So the P stands for the parentheses. Parentheses. E stands for exponents. M stands for multiplication. D stands for division. A stands for addition. and S stands for subtraction. And I'm going to group these together and these together. So essentially, we do all these operations in the order they appear. So let's go ahead and do number 34 to demonstrate this. Negative 6 divided by negative 3 times 3. What we're going to do is we're going to look at our order of operations right here, our Pemdas, and examine what we have here. So we do this in a hierarchy way. We do parentheses first if there's any, then exponents, then multiplication, then division, then addition, then subtraction. So we examine this right here. First, are there any parentheses? Here we do see these as parentheses, but as we learned earlier, parentheses like this make multiplication. So essentially, if I have something like 2 times negative 3, that makes negative 6. That's the same thing as saying 2 times negative 3. So whenever you see a number next to a parentheses like that, it means multiplication. So these aren't inherently parentheses, they're just multiplication. We see that we also have division. So we have multiplication right here, and we have division going on. So what we want to do is examine this. Multiplication and division. Multiplication doesn't necessarily go before division all the time. It's whichever one appears first from left to right. So when we look at this from left to right, we see that we have division first and then multiplication. So what we're going to do is we're going to do division first since it's the first one that appears. So we do negative 6 divided by negative 3. Negative 6 divided by negative 3, negative divided by negative makes a positive. 6 divided by 3 makes 2. So these two resulted in that 2 right there. We rewrite the 3 times 3. And then we examine Pemdas again. Are there any parentheses? Nope. No exponents. We do have multiplication. 2 times 3 is 6. And that would be our answer for that one. Let's try another problem. Let's do number 36 to further demonstrate it. Now, let me show you what would have happened if you did indeed do multiplication first. So I'm going to put this as an example. We're going to write the same exact problem. Say you did do multiplication first because you thought it came first on Pemdas. All right. Negative 3 times negative 3 makes a positive 9. So divided by positive 9. Negative 6 divided by 9, that actually makes negative 0.6 repeating. As you can see, this answer is different from that one. This answer would be incorrect because Pemdas wasn't done correctly. Let's do number 36. This one says 2 times negative 3 plus 5 times negative 4 minus negative 8. Let's examine Pemdas again. We don't have any parentheses. Remember, those are multiplication. No exponents are seen. I'll explain what exponents are here in a second when we find one. We do have multiplication, addition, and subtraction. So according to Pemdas, we have to do multiplication first because we see it here, here, and here. So let's do that first. 2 times negative 3 makes negative 6. The next one is positive 5 times negative 4. That makes negative 20. So we put minus 20. Minus negative 8. Remember, we can change that according to that other rule, make it into a positive 8. Now we can see there's no more multiplication. We didn't have parentheses, we didn't have exponents. There's no division. We can move on to addition and subtraction. And that's grouped up. Addition and subtraction are grouped up with this blue line because we do it in the order from left to right. Negative 6 minus 20 makes negative 26 plus 8. That then gives us negative 18 as our answer. All right, let's go ahead and try one with exponents, or we'll do one with a fraction really quick. Number 40, 7 plus 8 minus 13 divided by 1 minus 6 plus 7. This one's a little tricky. What we want to do is we want to simplify the top and the bottom separately before we do this division symbol right here. So these are inherently kind of like their own sets of parentheses. We need to do everything inside each parentheses first before we actually divide. So the top numbers we can add together. 7 plus 8 makes 15 minus 13. 1 minus 6 makes negative 5. 15 minus 13 makes 2. Negative 5 plus 7 makes 2 as well. 2 divided by 2 makes 1. And that's our answer. So we end up doing division last because we have to add everything in the numerator and everything in the denominator first before we do anything else. Now let's try one with exponents. So first let me show what an exponent is. An exponent is something like this. If we have some kind of number raised to another power, this is called the base. This is called the exponent of it. So 4 to the second power becomes 16. The reason being is because this top number right here represents how many times we multiply it. So we're saying 4 times itself twice. 4 times 4 makes 16. If we had something like 2 to the third, that would mean 2 times itself 3 times. 2 times 2 times 2. 2 times 2 is 4 times 2. 4 times 2 is 8. If I had something like, we'll say 3 to the fourth power, that means 3 times 3 times 3 times 3. You can multiply all of those out on your calculator, or you can do it one by one. Doesn't matter. It all comes out to 81. What if we have like a negative number? What if I have negative 2 to the third power? That's negative 2 times negative 2 times negative 2. Negative 2 times negative 2 makes 4 times negative 2. 4 times negative 2 makes negative 8. But what if I had negative 2 to the fourth power? Negative 2 times negative 2 times negative 2 times negative 2. Negative 2 times negative 2 makes 4. 4 times negative 2 makes negative 8. And negative 8 times negative 2 makes 16. So you can see this one became a negative, this one became a positive. And it has to do with the exponent. If you have an odd exponent, it's going to end up being a negative if your base is a negative number. If you have an even exponent and a negative base, your answer is going to be positive. You don't need to memorize that. Just know how to expand it, just like that for all of these. If you expand it just fine, you'll be good. We're not going to go into some crazy arithmetic and algebra in this class, just the basics. So another one, maybe I can do one more example. What if I have 1 to the sixth power? Well, remember that's 1 times 1 times 1 times 1 times 1 times 1. Well, 1 times itself, no matter how many times, is going to end up being 1. So let's go back and do number 41. Number 41 says 2 parentheses 3 minus 9 plus 4 to the second power. Remember Pemdas. And we kind of group up the multiplication, division, and the addition and subtraction. So according to Pemdas, we have to do P, which is parentheses first. Parentheses means do whatever is on the inside of the parentheses according to the rest of this. So we look on the inside of the parentheses, we have subtraction. We have to perform that first. So 3 minus 9 is negative 6. Rewrite everything else. We don't have any more parentheses. Remember, that's 2 times -6. It's not parentheses, -6 in the sense of order of operations. So E stands for exponents. We have to do exponents next, which would be the 4 to the second power. 4 to the second power is 16. So parentheses is done, exponents is done. Multiplication and division are next. C multiplication, 2 times -6 makes -12. No more multiplication and division. Now you just have to add them up, and that makes 4. So there's going to be some PEMDAS problems like that, illustrating the order of operations. Now, finally, lastly, we're going to deal with algebraic expressions. So let's talk about algebraic expressions. So an expression in math is a set of numbers, adding, subtracting, multiplying, dividing, or just a number by itself. So if I have something like 2 plus 3 to the second power, this is called an expression. If I introduce something else like an x, 2x plus 3, this is called an algebraic expression. Because it contains variables. So this right here is considered a variable, the x, meaning it varies depending on what we plug into it. So if I have something like, let's just say the same thing, 2x plus 3. That answer, if I was to substitute a value for x, like say if I said let x equal 1, that would become 2 times 1 plus 3. That becomes 2 plus 3. Your answer becomes 5. If I substitute a 2 in for the x, it becomes 2 times 2. That's 4 plus 3. That becomes 7. We can see our answer varies depending on what our variable is. So variables come in all different they'll come in all different letters and Greek letters, symbols. Doesn't really matter. A lot of common variables that we use in math are x, we use y, we use z, we use a, b, c. If you took pre-cal in high school or some time ago, you might have seen theta, physics. You might see some other ones like alpha, beta, all these other ones, omega. You might see all these different symbols. They can even be capitals. They can be like a capital A, a capital B, a capital C. All different variables. It doesn't matter what it is. It's just a number that substitutes in for another number later on. So let's think about how we combine variables. Let's talk about numbers. If I have 4 plus 4 plus 4 plus 4 plus 4. Well, we know 4 plus 4 plus 4 plus 4. That would make 20 if we add them together. But remember the rule, the multiplication property is saying how many times we have the number 4, right? So that's 5 4s. Instead of adding them all up, we could say 5 times 4. So that'd be 5 times 4. We have 1, 2, 3, 4, 5 4s. So 5 times 4 makes 20. Kind of goes off of that concept. If I have variables, though, instead, let's say I have x plus x plus x plus x plus x. Like here we had 5 4s. We put 5 4s. How many x's do we have? 1, 2, 3, 4, 5 x's. We just combine all the numbers in the front. If I have something like 2x plus 3x, we combine the coefficients in the front. These numbers right here, the 2 and the 3, they're called coefficients. Just combine the numbers in the front, that would also make 5x. So we can combine like terms if the variables are the same variable. So if I have, let's say, -3x plus 6x, combine the coefficients. Negative 3 plus 6 would make 3, and we're talking about x. So that's what it combines and makes. If I have negative 7x plus 4x, that would make negative 3x, because negative 7 plus 4 makes negative 3. If I have negative 10x minus 12x, negative 10 minus 12 makes negative 22x. That's how we combine the variables. Now you can only combine variables that are the same type of variable. So if I have something like 2x plus 3x plus 4y plus 5y plus 3z plus 2z, I can only combine ones that have the same variables, like x's with x's, y's with y's, and z's with z's. 2x plus 3x makes 5x. 4y plus 5y makes 9y. 3z plus 2z makes 5z. This would actually be your final answer. We can't combine any further because x, y, and z are different variables. It's kind of like apples and oranges, right? Like if I have, let's just say 3 apples and 6 apples, that would make a certain number of apples, right? This is the same variable when we're talking about the x and the x. But here we're talking about x and x, y and y, and then z and z. They're all different types of variables. So we can't combine all of the numbers since they're all different. It could be like apples for x's, oranges for y's, and I don't know, a pineapple for z's. It's not, those aren't inherently my favorite fruit or anything, it's just the most common ones, really. So that would be how you combine the variables. Let's try a practice problem. Let's try number 44. Say we have numbers and variables. 7x minus x plus 14 minus 9. We're going to combine like terms. So x's with x's, and then numbers with numbers. So if we look at this, 7x minus x makes 6x. 14 minus 9, since those are two separate numbers, they're not variables, we still combine them like numbers. That would make positive 5. This would be your final answer because we cannot combine variables and numbers. All right, let's try one last problem. Let's do number 46. 7x minus z plus 6y minus 5z minus 11x. Here we're going to do the same concept. Now, we can use something called a commutative property where the order that we add things in doesn't matter. As I mentioned that before, order you add things in doesn't matter. So I could switch them around. I could put the x's with the x's. I can put the y's with the y's. There's no other y's. And we can do the z's with the z's. So let's try putting the x's together first. Positive 7 minus 11. So positive 7 minus 11, you have to put those two together. That makes negative 4. The variable we're talking about is x. Then let's go ahead and do y. There's no y's to combine, so we just bring it down, put plus 6y. Then do the z's. This is a negative 1 minus 5. That would make negative 6z. And the reason why I did x, then y, then z is because we usually put them in alphabetical order. So just put them in x, y, z, a, b, c order, whatever makes sense. Now, if they're out of order, say if it's 6y minus 4x minus 6z, this one is still technically correct. They don't necessarily have to be in order. It's just mathematicians, we're a little picky sometimes, and we just like things to be in order. It makes it a little easier for us to read. Now, just be careful whenever you're swapping signs like that. If I have negative 2x plus 3y. Remember, addition and subtraction is commutative, meaning we can move them around. This is the same thing as 3y minus 2x. 3y minus 2x is the same thing as negative 2x plus 3y. Because when you move something, you move the sign that's in front with it. If I want to move it on the other side and move this on the other side, swap them out. So this stays as a positive 3 right here. This stays as a negative 2. You can do that with numbers as well. If I have 10 minus 4, we know that makes 6. If I swap the numbers around, I need to carry the sign with me. If I want the minus 4 in the front, I have to put negative 4. If I want the 10 last, that's a positive 10, I have to put plus 10. That makes the same thing. So be careful when you're moving numbers around like that. Negative 3 plus 9. I might want to move those around because I find it difficult to do negative to positive. So I put the 9 in the front, the negative 3 last, and that makes 6. So whenever you swap numbers, you got to swap the whole entire sign whenever you're moving numbers around. All right, well, that wraps it up for homework 2. It's a pretty long lecture. It covers a lot of different things. For homework number 3, we'll be covering solving algebraic equations, and that'll pretty much bring us to the end of any kind of algebra related stuff. Homework 4, 5, 6, 7, and 8 are relating more towards percentages, decimals, and then more cooking examples. So we'll get to the real world problems after homework 3. Go ahead and do the homework 2 on MyMathLab, and then you can move on to homework 3.